Welcome back to the deep dive. Today we are wrestling with what might be one of the most intellectually disruptive ideas to come out of the whole AI revolution.
It really is. It's a complete paradigm shift.
Right. It challenges, basically everything we thought we knew about memory, computation, and really the fundamental structure of thought itself.
Exactly. So we're diving into the generative theory of cognition.
Mm.
And the mission today is to really get our heads around this radical claim.
And the claim is what?
That the math that powers modern large language models, things like ChatGPT, it's not a metaphor for how the brain works.
Sure.
The argument is that it is the actual core cognitive algorithm, the operating system that you are running right now.
So if you're trying to get ahead of the curve in neurotheory or even just understand how something as complex as human thought emerges, this is a crucial deep dive.
Absolutely.
The core thesis then is that the brain is an auto-regressive model. And that means we have to, just throw out the old computational model, the one that's dominated science for nearly a century?
We have to. That model is classical computationalism, and it's based on the Turing machine. The problem with that whole framework is its reliance on, extreme precision.
Okay, let's unpack that contrast immediately. Because when we think of classical computing, your laptop, your phone, we think of a system defined by what the source material calls contingency and brittleness.
Yes. In a contingent, brittle system, every single step, say t plus 2, t plus 3, it relies perfectly on the execution of the step right before it.
Right.
So if there's an error way back in the calculation, a single misplaced semicolon in a line of code, the whole system breaks. It halts.
It's the blue screen of death.
It is the blue screen of death. The system stops, and it basically says, I cannot proceed. I have to go back.
Which, from an evolutionary standpoint, sounds like a terrible strategy.
It's a disaster.
If one neuron misfires, we just die. The whole system goes down.
Precisely. And that's where the autoregressive model is so powerful. It has just one rule, and it's beautifully simple. Generate the next token or the next pattern. That's it. And because it's always moving forward, always predicting, and it's never forced to backtrack or achieve some perfect state, it is inherently anti-brittle.
That's a powerful distinction. So instead of this rigid step-by-step dependency, the auto-regressive brain it keeps flowing no matter what.
The source uses this wonderful metaphor. The system is like a stream of water running down a hill.
Oh.
If the stream hits a rock, which is like a failure or a bad calculation, it doesn't just stop and go back up the hill to try again.
It just flows around it.
It just flows around the rock and continues its computation.
Yeah.
It computes continuously without ever failing, without halting.
The stream just runs. The simplicity is the strength. But okay, this begs the essential new question for neuroscience, doesn't it?
It does.
If the entire system is just running this simple, unbreaking next token algorithm, how on earth do we get the utility? How do we produce, complex cognition writing novels, astrophysics, philosophy?
That's the real work now. We've solved the unbreakability problem, but we haven't solved the utility problem. Figuring out how all that complex human function is built out of this foundational, fail-safe, predictive process. That's the new frontier.
And this foundational shift, it immediately and completely dissolves our common sense idea of memory.
It has to. We have to discard the traditional storage and retrieval framework.
The idea that we store facts like files on a hard drive and then pull them out later.
Yes, that entire framework is just poisoned by the old classical computational model. It's the wrong way to think about it.
But that's how it feels. It feels like I'm storing information about my childhood and then retrieving it. If I ask you right now to picture your mother's face, you're not pulling up a JPEG, are you?
Absolutely not. That feeling, that memory, it's an illusion of storage. When you picture her face, the system isn't retrieving a static image.
It's generating it.
It is generating that image in the moment based on its current structure and your request. You can command it to generate her making breakfast 30 years ago from the side with specific lighting. That potential to generate is what remembering actually is.
So memory is generation, not storage.
Correct. And that means memory is better reframed as influence. Past events don't get filed away somewhere. They change the parameters, the structure, the weights of your neural network.
Ah, okay.
And those structural changes then influence the current generation of your thought or your behavior.
That structure means the past history, it continues to have an effect. This sounds like that technical term I saw in the sources, non-Maruvian. What does that mean in simple terms?
Right. Think of it this way. In a traditional computer, when a process is done, the memory used for that can be completely wiped clean. That's Maruvian.
Okay.
But in the autoregressive model, past context never truly decays to zero influence. It continues to subtly shape the next predicted token. Your entire life history is woven into the very structure that's generating this next sentence, you say.
Wow, that also forces a huge rethink of working memory. We all learn about the, temporary holding tank for 7 plus or minus 2 chunks of information.
And that traditional view is completely flawed under this new theory. Working memory is not a store.
It's not a store.
No. It is the residual activation that's necessary for the autoregressive process to keep going, to generate the next functional output. You need to remember the first half of this sentence to finish the second half meaningfully.
So the fact that we can consciously access that small span of recent info, the famous 7 chunks, is just an epiphenomenon.
Exactly. It's a side effect. It's a byproduct of the system doing its real job, which is generating the next thing. It's not the functional purpose itself.
So what we really care about is
runtime performance, the ability to generate meaningful, effective responses and do the right thing in the moment. Your ability to recite 7 random words you just heard is, interesting for a psychologist, but it's useless to an organism trying to survive.
So if runtime performance is the only goal and memory fidelity is basically irrelevant, that completely changes the game for cognitive enhancement and how we measure it.
Absolutely. The focus can no longer be on how well we store facts for retrieval later. That's just the wrong objective.
So the new approach to enhancement is what?
It's figuring out how to nudge the system, that continuous cognitive stream, in real time to help it take a more optimal, more functional shape.
So instead of focusing on input, like cramming for a test, we should be focusing on process sculpting, looking for the right points of intervention to shape the ongoing generation.
Exactly. And this requires a serious revaluation of how we even test cognition. The source is highly critical of this. It calls traditional short-term memory experiments, which only measure explicit retrieval.
Yeah.
It calls them far too crude and, frankly, a misguided measure.
Misguided is a strong word. I mean, explicit retrieval tests are critical in things like clinical diagnosis or, educational metrics measuring students' grasp of a topic. Are you saying those are useless?
I'm saying they measure the wrong thing. They measure what is easiest to measure, not what is functional.
Ah.
In the real world, you need flexible problem solving, not perfect recitation. If I test your ability to recall 5 random words, I am testing the epiphenomenon. I should be testing your ability to generate a solution that is influenced by those 5 words.
So we need a new kind of psychophysics, one focused on efficacy and functional outcomes. What would a new experiment even look like under this paradigm?
Well, we'd move beyond these binary understand, don't understand measures. We'd move toward softer metrics that can capture variance in performance.
For example?
For example, you give someone a set of really complex instructions, and then you measure their runtime efficacy, their capability to carry out that task efficiently and flexibly.
And then you could experiment with the nudges.
Precisely.
So you inject a piece of reinforcing or maybe conflicting information at step 3 of the instructions. And then you measure how much that intervention, positively or negatively, influences their ability to complete the full 20-step task successfully. You're measuring influence, not fidelity.
You're measuring the efficiency of the generative stream. And that is how we move enhancement from a storage problem to a process optimization problem.
This entire framework, built on how language models work, it forces us into a pretty profound philosophical whirlwind. If the brain is built like an LLM, what does that tell us about language itself?
It tells us that language is an astonishingly self-contained auto-generative system. I mean, think about it. LLMs are trained entirely on text, just the statistical relationships between symbols.
Right. They operate completely divorced from any physical, sensory, or experiential grounding.
Exactly. They never feel the heat of a stove or see the redness of an apple. They never have access to the actual physical objects or phenomena that words are supposed to represent in the real world.
And yet they produce meaningful, human-like language.
Right. And if that symbolic language system is primary, the source makes a really controversial assertion.
Which is?
That the famous unreasonable effectiveness of math in physics is actually derivative of language. That math is a human artifact that just borrowed its concepts of symbolic representation from the larger linguistic system.
So math is just a tool used by language. It's not some universal truth we discovered.
That's the argument. And it flips the whole hierarchy of knowledge. Which brings us right back to philosophy's oldest puzzle, the mind-body problem.
Yes. The persistent gap we feel between our minds and our bodies. The sense that thought is somehow separate from physicality.
It may exist because linguistic cognition is inherently divorced from sensory experience.
There's a disconnect between the mind that speaks and the mind of experience.
Exactly. The mind that speaks is the objective, symbolic, autoregressive system. It operates in the world of language. The mind of experience is the body. It's the thing that sees, that feels, that possesses qualia.
And qualia is the technical term for that subjective felt experience, what it is like to see the color red, or smell coffee, or feel pain.
And that felt experience is completely inaccessible to the purely symbolic linguistic system. The LLM brain can talk about the color red all day long, but it can never grasp the actual feeling of redness.
And that inability, that gap, is what we've been struggling with for centuries.
It could be, and this is deeply unsettling. If our ideas, our concepts, our knowledge are all fundamentally linguistic,
The lifeblood of our thought.
and we now understand language to be this social, communicative thing that generates itself,
Yeah.
it doesn't really live inside any one individual mind, does it?
No.
The uncomfortable conclusion is that the very informational system that's doing the talking right now, the core of our intellect, it belongs to a collective informational system that is larger than us. It lives outside the boundaries of the individual skull.
The source material says the speaker feels almost parasitic.
Yes, as if the thing doing the talking isn't the thing doing the feeling.
That redefines what knowing something even means. If knowledge and understanding are linguistic, and we have this radically new take on what language is, then the core questions of philosophy, of intellect, of individual identity.
They all have to be redone.
Yeah.
From the ground up, the foundation has completely shifted.
So let's bring this all back to you, the listener. We've established the brain is an unbreaking autoregressive stream, and memory is generation and influence, not fixed storage.
The practical implication there is huge. Your focus has to shift entirely from how do I store this information with high fidelity for later retrieval,
Sure.
to how do I encourage the right kind of influence to shape my cognitive stream optimally for maximum runtime performance today.
So learning moves from being an act of, like, storage management to an act of real-time process sculpting.
And that profound shift from seeing the physical bounded brain to recognizing the linguistic self as part of an external collective autogenerative organism, that is truly the most powerful takeaway here.
So if the linguistic self that performs this deep dive is separate from the experiential self that feels it, and that language is a collective organism that runs through all of us, who then is the actual me performing this deep dive right now? Who is the I? That's a question for your autoregressive stream to wrestle with until the next time we dive in.